The first June, right? First June GFG question. Count pairs sum in matrices. So we are given two matrices and a target value 21, and this is n refers to the size of the matrix. The dimension are destined to be same, right? 3 cross 3 matrices, like not fixated on 3, but they will be same. The matrix 1 dimension and matrix 2 dimensions will be same. So basically we have to find the pairs that sums up to this particular value 21, like 20 and 21, where 1 is from the first matrix, and like this one, and you take this 20, they sum up to 21, right? You cannot take two elements from the same metric. You have to take one from this metric and you have to take one from this metric. Now, one thing that I would like to criticize about this question is that it hasn't given enough details about how the pairing should be done. Like for example, in this example, in this first example, there is no ambiguity. Like there is literally no ambiguity in every example. But basically what I'm saying is that they have not mentioned all the details clearly. For example, suppose, like consider how is pairing is done here. Like see, here 10 and 10, this 10, this one and this one are paired, right? But suppose there were duplicates, like for example, here is also 10 and here is also 10. Now, how would you pair? Like, first of all, they have literally mentioned nothing about duplicates. So, would you pair this? Would you consider these two different pairs? Now, you might assume, okay, fine, we will consider this different pairs, but still there is some issues. For example, you can consider this 10, 10 a pair, right? The middle one. Then you can consider this 10 and this 10 another pair. This is how they assume that the other person sitting beside the screen will understand this, right? They have literally not mentioned it. But like if you actually do all the pairs, it should be like, see this one, the focal. Let me get the pencil. Okay, so this, oh my god, this middle one, this 10 and this 10 can be one pair. Now the same 10 we pick from matrix 1 and we pick another 10 at another index from matrix 2. This can also be a pair. Now this 10 and this previous one can also be a pair, and this 10 and this new 10 can also be a pair. So there are 4 pairs according to me. Like if you have not mentioned, I would write code like this to assume that this is how you expect the pairs to be. But here they have mentioned, they have literally nothing mentioned, but they assume that we have to take the index wise. Like you cannot use one index twice. Like if you have made a pair with this index, you cannot use this index in another pair, but you can use the same value again, like, right? So basically what I'm saying is that they should have mentioned something properly, but whatever. So this was I was trying to tell you. Okay, so let's get back to the question, and let's discuss 3 approaches. First is brute force approach. What is brute force? You literally do n square, and that also square, so n raised to 4 traversal time complexity. There is no space complexity in the brute force because you just traverse and you just generate all the possible pairs and you find the number of counts and all that, right? But in that also you have to consider this thing that I mentioned here, right? You cannot count this 10 versus this. If you count this, you have to move away from this 10. You can use a particular index at most once, right? So that is the first thing, right? So that is how you can do the brute force. What is another approach? Another is that you can, if you have done the 2-sum problem, you can use that approach, like that is hashing. But that was in the 2-sum we were using hashing because the array was not sorted. Okay, I'm sorry, I forgot to mention a critical detail, that both the matrices are sorted, right? Both, like starting to end, like literally if you convert this in a 1D array, it would be sorted, right? Not just column wise, not just row wise, entirely sorted. Okay, so that is a thing to mention. If the arrays were not sorted, you can use this 2-sum hashing thing. That would be the most optimal solution, but in that we are not actually utilizing any kind of sorting functionality, right? So if they are sorted, we should use that property, right? So the best approach is here 2-pointer approach, right? You might have already guessed, they are sorted. You just have to find the pairs. So basically you start from having 2 pointers. Now let's don't confuse about how we are going to initialize our I and j pointers for the matrix. That we will consider later. First just learn the approach. So for the approach, we will put our one pointer, I pointer. We are going to have only 2 variables, I and j. Okay, so I pointer would be initialized by 0 and j pointer would be at the end of another matrix. I pointer is for the matrix 1, j pointer is at the end of second matrix, I is at the beginning of first matrix. So I is at 1, j is at 20. We compare them. Is this sum greater than x, or first it's equal to x? So yes, it is equal to x, 21. So you add this into your result or whatever. Okay, you just have to return the count, right? You don't have to return this all. So just you increment the count. So then now, since that all thing that I told you about, this ambiguity and all, so you just move away from this value because you cannot use one index again, right? That is, you're supposed to assume somehow. So okay, so you move this. So you move the to the 16 here and you move to the 5 here. Now you compare these. This is also I think 21. So again you add a pair, then you move to 6, right? Here it is 6 and here it is 13, that is I guess 19 maybe. So that is less. So what do? You have to increment the value, the summation that you're trying to get. How do you increment? Like if you move this forward, this to the left, you will get 10, right? But this is sorted, so this will only decrement the value. There is no element that is greater than 13 on the above part of these metrics. So if you want to increment a value, you of course have to go down here. You have to increment this I pointer. This is simple logic, right? You go to 8 and then you find again a pair and all that. You can continue this until either I reaches this 18 or beyond, or either j reaches before below 0, right? You can continue till that part. So you can loop through a simple while condition. Now let's talk about how we're going to deal with the pointers. Like from I, how can we derive this 2? We would need 2 pointers, right, for each matrix. Like, yeah, so for example, it is simple actually. You can do this by division and modulus properties. Like, for example, consider the value of I to be 2. So basically what this means we are referring to the second element of the matrix. We don't care about the row and column, that we will derive somehow. So basically row is equals to this I divided by the n value, and column is equals to this I percentage n. This was actually not second index, so third elements. I is equals to 2 refers to the third element. I is equals to 0 refers to the first element, and that's how simple indexing. So for example, basically if you consider this 1, 5, 6 and all, so basically if the value of I can range from 0 to, let's say, 8. This 1 represents the 0 and this 18 represents 8. Now how will you come to this actual 18 value from value of I is equals to 8? By this formula. So the row is 8 by 3, right? And the value of n is 3. So 8 by 3, which is going to be 2. And the column is 8% 3, which is again going to be 2. And this 18 basically is second row, second column. That is how you can deal with the pointer thing. So this is the simple code. You initialize the pointers and count is equals to 0. You traverse till this condition. This is these formulas that I just told you, summation, and we're just dealing with the pointers. Here we move both of this because, right, that indexing, right, you can use one index only once. So that's it. Thank you. Okay, let me also submit this to prove you. Right. Thank you.